as we set up, just to relate what we're showing you now to the initial goals of the project, we sought to develop an open architecture to address the patient identity aspect of the needs for a collaborative kind of open source platform, which could really be owned and controlled by the patient and would put the patient in the driver's seat by having all of the information architecture around it, to the apps and the devices and the services of the patient's lives, in a way really designed to be patient-centered, under the patient's control. See how the patient's at the center of the world? Actually, that's a different So we did exactly that. By relentlessly focusing on the collaborative use case using IndivoX with its implementation of OAuth and looking at the authentication and authorization standards that are currently implemented in the industry, we sought to intelligently piece together those components in an architecture that would allow, eventually we postulated, open marketplace for these kinds of devices and services. So the goal was a patient identity service for a collaborative health record that's openly accessible from home, doctor's office, pharmacy, and a simplified patient-centered login and linking of the data. So as we see this kind of data from a Connect, for example, in theory, it would go directly into a personal health record, Indivo in this case. How would that actually happen? And would every application have to rebuild unique sets of code in order to allow for patient authentication and authorization and linking of the data? That wouldn't be the very best use, and we don't think that would develop a truly patient-centered market. And so we wanted to come up with open source, open standards, reusable components for that. This is just a look at the way the government sees the current environment. It comes from the Health IT Policy Committee, and you'll notice that the authentication environment here is really focused on the providers, doctors, nurses, clinics. Go to the next slide. This is an eCitizen and Kantara view of what we think is a broader context, which includes the patient, a personal health record, and then at the back end, devices, electronic medical records, and the rest of the healthcare systems. So this is just going up to 50,000 feet, what we think is the broad architecture. And now the next slide, if you go down, we now drill down to what we think are the key value moments that the user experience would involve to reuse these components and make it easy and sensible for a user to connect their data. The first thing would be not a username and password for every device and for every application and for every service, but something like a reusable open ID. In this case, not from a commercial social network provider, but one that we think would be clustered for and appropriate to healthcare, like a open ID for healthcare, an open health ID, which a patient would click on. And they would only need to know one username and password, and you could build on that public key cryptography, near-field communications, other methods and factors of authentication as appropriate to the transaction. But the idea is it would be a reusable component that could be clicked on just as easily as people currently do their home banking. The next thing you'd have to do, of course, is link the data. So we think a common reusable experience for that would be appropriate. This doesn't look so different from Facebook Connect, because that's what we stole the image from initially, and then we extrapolated what would it take not to have completely unbounded, open, and lowest common denominator data linking, but how can we use OAuth, XACML, and some of the other standards in a healthcare context to allow fine-grained control by the patient over what data and applications and services are linked. Something that looks like this would be appropriate at the user end, we postulate, and the tools and technologies and configurations are what it is we've been working on. This shows the types of user interfaces when you have open source and open standards that you can develop. This was developed by John and his team as an example of how it is you can actually apply the fine-grained control with a user dragging and dropping data elements from the personal health records onto the faces of people and groups that they would like to share with. That's a very fine interface, and these tools and technologies enable that. At the back end is where the complexity is. You can't have no complexity with fine-grained, highly regulated, and somewhat high-risk privacy requirements. And so this is a diagram of how extensible access control markup language, XACML, would be applied at the back end to have user-controlled access policies and a rules-driven, service-oriented, real-time, kind of runtime architecture to allow these rules to be applied. And finally, this is sort of like the payoff at a high level. We postulate that if you use these types of tools in this type of reusable way, where you could swap in and out, you know, an IBM component or a EMC component or a Google component at each layer of the stack, what you get is an open architecture. So that any device manufacturer for a glucose meter and a smartphone and a better mousetrap with a Kinect can apply a few simple standards in, you know, well-known developer libraries like SourceForge and other places, and then what you get at the end of the day is a marketplace of solutions that again puts the patient in the driver's seat.
So Daza gave you the view from 30,000 feet that we've sort of been using to sort of guide this work. The feedback we got on a checkpoint last week was, that's great, we need to focus in on something more tangible. So we've had a number of folks from our technology team at EMC, Nihar Nanda and John Field, have been looking at how to actually implement this as a sort of reusable set of code standards and templates that we contribute back to the community and sort of help solve this problem for all future developers going through to implement this. So we've been working on setting this up. I would love to give you a live demo, but it turns out that the fastest way to shut down a series of corporate Java developers is to hand them a Python script based application, because we had everything set up and then we went to go modify the Indivo login scripts, which are all written in Python, and we went, eh. So we're continuing to work on that. We're actually going to recruit some more Python developers based on our Shanghai team to finish off the actual integration work. What we have done is we've actually set up an OpenID server, we've set up an Indivo server, coordinated a whole bunch of the stuff on the logins, all that kind of stuff. We're going to document that for the group. Then we're actually going to implement that on Indivo and hand that back as a set of code to the larger community, so that this becomes a solved problem for us going forward. You can then basically plug in whatever you want to use for your OpenID and an OAuth service, and then it'll just pass right on through. So in lieu of a live demo, of course, what I've done is done one of my famous PowerPoint animations. So this is real quick. What we're really trying to shoot here and show is that, and we're doing it in a very simple way, which is basically overriding the login process that you would normally go through in Indivo. Essentially rewiring the login capability in Indivo's normal login applications. So you hit a login page. Instead of providing user ID and password for that local instance, you hit the My Health ID Connect, and you're prompted for your My Health ID credentials. Or if you already have a cookie, that cookie then passes you on through. You then basically authenticate to an OpenID server. So given these credentials or this cookie, I go up to the OpenID server, I authenticate, is this really the person who says it's supposed to be? And then what I do is I get a set of credentials that come back, and then I use that. This is the animation part, this was the hard part. Come back and then use that to correlate back to an actual account in Indivo, which I actually have access controls to. So now I'm actually authorized to be able to perform certain functions now. And then the last sort of piece of this demo that we're going to submit back to the group is essentially have a display page that you default to that pulls back some OpenID information, maybe address information, all that kind of stuff, additional information that's stored in your OpenID account that's common across everything, and then migrate that back and display that with some information that's stored about you in the Indivo account. So you essentially now have an ID that's consistent across a number of different databases. And again, this is critical. This allows you to be able to port that ID through a number of different applications, which means it's a natural accretion point for your personal health record information. So again, we're sort of think this is one of those enabling technologies that allows it to be an open standard approach as opposed to individual silos across each one. This was the actual use cases we used to drive that. Next steps, obviously we want to actually complete this into working code and submit that back. We're doing a Java implementation because there are still some of us dinosaurs that like to use Java. We're also going to do this in Python, which is sort of the base implementation for Indivo. We see this as potentially being used across different devices. We're doing it basically at the web level, but you'd also want to do this on an intelligent smartphone or a pad device as well. But we also want to do it across different back-end boundaries. We're targeting Indivo because Indivo is the common platform for this research, but Indivo is also used in a number of areas. We'd love to see this implemented across, say, Google Health, Dossier, WebMD. There's a number of different target PHR targets that would be interesting to take the same approach to. And obviously, we'd like to be able to do this, do some access management. So implement some of the ideas that John's been doing with access controls and who can see and work with your information. Actually implement those into a functional prototype that we're going to use to demo. We really look at the work that we've been doing here with Daza and with John as a stepping stone to some collaborations with a number of other sponsors. And we have some great conversations with the folks from Cisco about this. What we really want to do is use this as a focal point to build a lot of this concept and implement it with some of our own healthcare management tools based in EMC, and then use that to evangelize these to other sort of corporate brothers and sisters out there in the universe as a way for self-insured people like EMC to be able to manage this and actually enable our employees to help manage their healthcare a bit better.
So the hope is going forward, those of you that have projects that are creating data would be able to work with you and actually hook them up through these open, to the extent you have authentication and authorization up to synchronize with the Indivo record. We want to work with you and enable these academic research implementations and thereby lead the way to show how market adoption could occur through EMC and its partners. Thanks.
Excellent. All right. Excellent. So I'm very excited about some the steps that are being taken here to get some of this implemented. The highlight at the end of the day is that if patients can have one record that tracks all of their health information, they can be very sure about its security. They can easily share it outside of that health record, which is what OpenID will help them do, to have a more generalizable ID associated with that. And then some of the exciting work that they're talking about challenging people with different credentials depending on the importance of the data that's being shared. So you might have to authenticate with your password and also with your device with using near-field communication. And you may have to provide some other biometric authentication if it's really higher level data such as genetic information or other traits that you have. So that's really exciting that we can start to build these into tools that are shareable, that other people can benefit from, and have high security but also high usability. Nice work.
Identity enables privacy and personalization.
Yes.
Can finally square the circle with this tool.
Excellent.